In this chapter, we will be talking about chemical equilibrium. The goal of this chapter is to understand what we mean and specifically how dynamic equilibrium relates to the forward and reverse reactions. In equilibrium, we are concerned about how far the reaction proceeds because when we first learned about chemical reactions, we assume that the reaction goes to completion, meaning that essentially all of the reactants are consumed in creating product within the constraint of the stoichiometry of the reaction. For example, hydrochloric acid reacts with sodium hydroxide to produce aqueous sodium chloride and water. If 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide, and then measure the amounts of product which is produced, we would get essentially 1 mole of sodium chloride and 1 mole of water. That is exactly what we would have expected by the stoichiometric coefficients here. 1 mole of hydrochloric acid plus 1 mole of sodium hydroxide should give us 1 mole of sodium chloride and 1 mole of water. And that suggests, in fact, the stoichiometry is doing exactly what we would expect it to do. But in reality, many reactions do not go to completion. What we get is some portion of the reactants are converted to product, and then we don't see the formation of products continue to increase. So this is when the reaction reaches a chemical equilibrium. For example, hydrogen gas reacts with iodine gas at 490 degrees Celsius to produce hydrogen iodine gas. Again, if 1 mole of hydrogen gas reacts with 1 mole of iodine gas, we would expect to produce 2 moles of hydrogen iodine gas according to the stoichiometric coefficients of the balance reaction. However, we only get 1.54 moles of hydrogen iodine, which is not consistent with the stoichiometry. This suggests that the reaction does not go to completion. We did not get all of the hydrogen iodine that we may have expected to occur. Instead, we observed that the reactant and product can coexist simultaneously at specific observable concentrations or pressures.